So I will show you the most common way on how to measure unconscious processing in the psychophysics psychology literature. Maybe we better understand what consciousness is or what we mean by it once we understood how it's measured. Then I will show you the flaw with this standard reasoning of showing unconscious processing, and that the evidence in the literature is actually substantially lacking. So I will show you how they try to do it, how they fail, and that there's actually little evidence for unconscious processing from psychology. So if you look into the literature, unconscious processing or even implicit processing, we will hear a short sidetrack on this too. It seems ubiquitous. There are reports that lie detection can be done unconsciously. So you do not consciously perceive if someone is lying, but unconsciously somehow you track whether the other person is lying. You can do maybe perception, even learning unconsciously, so without the impression that something happened. Memory, all these things, even reading arithmetics in the sense of you see 5 plus 7 and without your consciousness present, maybe you can add these things up. With all these reports, and you find a lot of these in the literature, the question becomes, what do we need consciousness for if all of this is possible unconsciously? And it even goes so far as to suggest that if our unconscious processing is supposed to be better, for example, in lie detection, should we just stop deliberating? Should we stop thinking? Maybe we just turn off our conscious process. And this is not an exaggeration. The Dijksterhuis unconscious thought theory suggests that if you have a complex decision to make, you better not deliberate about it. You feel with your gut, and at some point the decision comes out. So with so much at stake, with such strong claims, there is of course a big debate about it, and many other voices criticize the proposals that are done here. And we will focus today mostly on one particular critique here, and that is basically on the perception part. If we get to it, we will also go for the unconscious or implicit learning part, where I've worked on during my dissertation. So the question now is, how is unconscious perception proven in the psychological literature? I brought you the most typical standard kind of paradigm, the priming paradigm, which is based on the seminal work of De Haan et al. De Haan is one of the main people in consciousness research, proponent of or founder of the global neural network workspace hypothesis, which is the most prominent consciousness theory. So this is his experiment in 1998, and it basically looks like this. You put a participant, a human, in front of a screen in a dark room with a monitor. And the participant sees the following sequence of pictures on the monitor. First, a random letter sequence. Then a prime. In this particular case, the prime is the number 4. And this prime is shown only for 43 milliseconds. This is a fraction of a second. This is very, very short, just a short flicker. Afterwards, another sequence of letters. And then the so-called target stimulus, this is here the number 6, for a little bit longer, 200 milliseconds, still relatively short, but you clearly see it. And then you have either of two tasks. So this sequence of pictures, sometimes with a 4, sometimes with a 6, sometimes the numbers are different, is repeated over and over hundreds of times. And in each of these trials, the participant has one of two tasks. Either the participant has the direct task, and that is to discriminate the prime. Basically press a button to say whether the prime number is smaller or larger than 5. Because the prime is so shortly presented, this is pretty hard. And then the other task, the indirect task, is you have to respond to the target and indicate whether the target is smaller or larger than 5. Because the target is relatively well visible, participants are able to do this. But the interesting kind of pattern of results is this. If you discriminate the target in the indirect task, your response time is faster, here 24 milliseconds faster in their experiment, if target and prime are both larger or both smaller than 5, congruent, than if they are going in opposite directions. A very classical congruency priming effect. Very robust, there's no doubt about this effect. But then if participants have to discriminate the prime stimulus because it is shown, and the masking basically tries to get rid of your after image, so this letter sequence here tries to get rid of your after image on the retina so that you really don't see the prime, and it shows that participants are quite bad at it. So if 50% is chance level, they're at 54%, which is in the margin of error in their experiment. If you're familiar with signal detection theory, sensitivity is 0.2, close to the chance level of 0. Okay, if you're not familiar with signal detection theory and sensitivity, in the following what I'm talking to you, just substitute sensitivity with accuracy, right? Here, sensitivity 0.2 corresponds to the accuracy of 54%. This is close to chance level. And then this is...
And is this being regarded as subconscious?
This pattern is interpreted as unconscious, yes.
So 54% is regarded as unconscious.
I will go into the details. So I think the literature basically or the common reasoning is it's not significantly different from 50%. Therefore, but we have problems with this. You can already guess it. Just to drive this home, you find this reasoning everywhere. You always have a task, participants don't see something because they're bad at discriminating it. They are close to chance level, but it has some effect. And it's an appealing reasoning intuitively, right? Like, the prime must have been processed, otherwise you don't see this reaction time effect. If participants did not process the prime at all, there would be no difference whether the prime was congruent or incongruent to the target. However, the participants, when asked directly to give conscious reports, they are pretty bad at telling what it was. Hence, processing that was not aware, unconscious processing. The reasoning formalized is kind of like this. You basically say this response time effect suggests that the indirect task performance, or the indirect processing here indicated by I, is larger than 0. So you have an indirect effect, and the direct task performance is assumed to be 0 without awareness, and therefore unconscious processing. In terms of Thomas Schmidt's and Dirk Forberg's dissociation paradigm, you basically live in the space somewhere. On the x-axis, your conscious performance, on the y-axis, your unconscious performance. And you are somewhere where your conscious performance is at 0, and you are slightly above that, or even highly above that in the indirect task, where you actually see that there's some processing. I think I reversed the colors here, so this should actually be blue, and on the x-axis should actually be orange. And so if you have such a situation, you need to still make some assumptions to come to unconscious processing. You first need to assume that the performance in the direct task, this bad performance here, is exhaustively measuring the capabilities of participants. Because you do this over hundreds of trials, participants might get bored or less motivated. And so if then they just have a lower performance just because of these motivational factors, of course you can't infer that they didn't have any conscious processing. You need to assume exhaustiveness. You also need to assume that the reaction time effect purely gains information or is driven by unconscious processing. But if you make this exhaustiveness and exclusiveness assumption, then participants are assumed to be unconscious. And here's the problem with this. This one is a fallacy. Just because the sensitivity or accuracy is not significantly above chance does not mean that participants are exactly at 0. So, Deutsche Bahn example, if it says the train will arrive at this particular point, it will never exactly arrive at this particular point to the nanosecond. It will always deviate a little bit. So in this case, in this sense, participants always have some maybe residual awareness, maybe are a little bit above 50% chance level, have some residual performance. So here, for example, 54%. Let's take the 54% seriously. Let's assume participants are just a little bit above chance. Then we wonder whether the indirect task performance is actually larger than what participants are consciously aware of, larger than the D here, right? If we say that D does not necessarily need to be 0, like there's no proof that D is exactly 0, the direct task sensitivity could be 0.2, for example, then the question becomes, is this I, this indirect task performance, actually larger than 0? So what we are basically asking here is, or saying here is, the first thing is very hard to prove. And instead, we replace this kind of idea of showing that the participant is perfectly unaware of the stimulus and has some processing. We replace this by saying the processing in the indirect task, the reaction time effect, is indicative of something more than what participants are aware of. This is already our argument. We already say, well, a study that tries to make their argument is supposed to show us that there's more information processing underlying the response times or any other indirect measure of processing, more indirect processing than what participants can consciously report. Only if there is more, we would attribute this more to unconscious processing. So the argument that is often done in the literature is problematic in itself because you cannot show d equals 0 exactly. And we say, well, show us at least that there's something more than what participants can consciously report. In the dissociation paradigm, basically, we don't ask you to be exactly on this d equals 0 line, here, this shaded area. We just need you to be somewhere in this upper triangle. Right? You just need an indirect effect that's larger than the direct effect. And then this larger, or this more of, would be maybe processing that's beyond conscious processing, unconscious processing. And it's important to note that if I now say we want this indirect task advantage, we call it, higher indirect and direct performance, this is a superset of the upper one. You cannot have evidence for the upper one if you do not have evidence for this. Right? Whenever someone shows you I is larger than 0 and d is equal to 0, they can automatically also show I is larger than d. So we are not requiring something more, we are requiring something less. So what we are saying is, oh yeah, you have this nice fancy setup with a priming, you show an indirect effect and a direct effect. Now please convince us that there's something more than in the indirect than in the direct performance. And I will then argue that we don't find this. Okay, that's basically the overview of the talk. The standard reasoning is the upper one. We say, well, if you claim this, you at least also claim this. And I will show you that the psychophysical literature does not hold what it claims, does not deliver what it promises. So let's see how this is. So basically what I'm saying is I believe the situation, and I think our data somehow indicates this, the situation is something like this. There's some residual direct performance, so it's a little bit above 0, it's a little bit offset to the right, but it's kind of on the diagonal, so there's not much more in the direct than in the indirect. So basically the two are not the indirect is larger than the direct, but they are on the same level. Why? Or what is the main idea? When Professor Franz came up with the kind of basic critique in 2015, he would have argued something like this. So I take you on a thought experiment just to understand my basic argument here. The thought experiment is, let's say we are in a maternity ward. And many babies are born, some are girls, some are boys. These babies are then weighted. And we sit in a cabin, someone comes in and hands us a piece of paper that says, the baby that was just born weighs 3,800 grams. Our task is to say whether the baby was a girl or a boy. Now, baby girls are a little bit lighter than baby boys, roughly by 100 grams. But there's a large variability between babies. So some baby girls are heavier than some baby boys and vice versa. So the effect is something like 100 grams is the difference, and the standard deviation within the boys and within the girls is roughly 400 grams. So if you really try to do this task, and if you did your best at the task, which would be something like you define a threshold here at maybe 3,550 grams, every baby weight that is larger than 3,550 grams, you attribute or you predict, oh, this must have been a boy, and everything below you predict it must have been a girl. If you do this, your performance will be quite bad, 55% correct or a sensitivity of 0.25. Okay, very simple. But on the other hand, if you now sampled, say, 3,000 baby boys and 3,000 baby girls, you averaged their mean weights, you would find a very clear mean effect, and you would almost always reliably see that the boys are 500 grams heavier than the girls.
Langweilig.
This is exactly what I've shown you before. You have a very clear mean effect in the reaction times, and you have a very bad accuracy when trying to predict from trial to trial. But both comes from the same information source, the baby weights. And I hope you all agree that in this situation, if you find a bad accuracy in the one way of analyzing or looking at the data, and a clear mean effect in the other way of looking at the data, no one of us would interpret that there's some unconscious knowledge about the baby's gender or sex. Yeah? But this is exactly the pattern of data that is presented to us. We have a low accuracy when trying to, from a trial-to-trial basis, identify the prime stimulus. Low accuracy, and you have just a mean effect of 24 milliseconds, very clear and very substantial in the indirect task. And our question is, maybe does this just come from the same information source, maybe the same conscious processing that generates responses in both tasks. And then if that was holding true, there would be no reason due to parsimony to infer that there's some unconscious processing independent of conscious processing. Yeah? It would just be one source of information, one processing that happens that produces both. So how do we show this? How do we actually compare the response time effect to the accuracy or sensitivity in the direct task? And our solution, or Volker Franz's solution here, is the following. We take these response times. These are over multiple hundreds of trials, many, many trials. Some are congruent, some are incongruent. Response times are roughly log normally distributed. And so you have many of these trials. And what you can do is you can perform a median split. You basically take all the response times, you go to the center of this distribution, and you say all the response times that are larger, so slower than this median, are predicted to be incongruent, and all the response times that are faster are predicted to be congruent, because congruent trials produce fast reaction times, and incongruent trials produce slow reaction times. This is an ideal observer analysis. So this is what the ideal observer could do with the data if they got it. An ideal observer gets the reaction time data. Please tell me which trials are congruent, which are incongruent. What is the prime? Is it congruent or incongruent to the target? So the ideal observer cannot do better than this when trying to predict what the prime is. And then you just compare this to the true label, whether the trial actually was a congruent or incongruent one, and you get some accuracy or sensitivity based on the reaction time predictions, based on the predictions made on the ideal observer model on the reaction times. And finally, you then compare this sensitivity that you got here to the sensitivity or accuracy that you got from the direct task. And the idea is then there must be a difference. If you claim that there's unconscious processing, something that's some more information processing in the indirect task than in the direct task, the accuracy that you get out here from the reaction times should be higher than the accuracy that you get out up there from the participants' conscious responses. And only if you have such a situation, there's empirical evidence for unconscious processing. You might need to make more additional assumptions, but this is basically the idea. This is what we are going to check for in the data now. This analysis is based on the idea that you have the trial-by-trial data, that you have maybe hundreds of trials from each participant, congruent or incongruent, and you can basically do a median split. Unfortunately, some of the studies are 20 years old, and I'm not sure whether you ever tried to ask another researcher whether they have their data from 30 years ago. I'm not sure whether you could produce, I'm not sure whether I can produce data from 30 years ago if I had them. So we had to come up with an analysis that works without this. Yeah. Exactly. This makes them comparable at all, because there's no comparability between a 24 millisecond effect and a 54 reaction time, 54 accuracy. This is really the core idea of what we are going to check now, to say, is there really more information in the response times than in the conscious reports? The next slide is what I've worked on for a long time, but might not be conceptually so important. It's basically just a way to get to this accuracy from the reaction times if you don't have the full trial-by-trial data, right? And so this slide is supposed to intimidate you. It's just a lot of math that basically says these response times that you often see in the literature in these papers that say, oh, there's a reaction time effect between congruent and incongruent trials. You see t-tests within subject t-tests usually. And these t-tests basically are the thing that we can base our reanalysis on, so that we ultimately come up with a sensitivity estimate based on the t-value. So basically, this was what I spent part of my PhD on, evaluating the situation, making standard model assumptions following Wouter and Half, and also this just a standard basically statistics literature that says, well, the t-value that you find that indicates this response time effect, which is often reported in these studies, can be used to infer back what the sensitivity/accuracy in the indirect task was. And for those who are familiar roughly with hypothesis testing with a t-test, you can see that here the sensitivity is larger the larger the t-value is, because larger effects indicate larger produce larger t-values. The number of participants comes here in the denominator. So the more participants you have with a fixed t-value, the smaller the effect is. Because if you get more and more participants, you at some point get any effect significant. The t-value will at any point be large enough. And so you basically have to account for, oh, you sampled 1,000 participants. That means your effect was not so large. The same is true for the number of trials here going in K. And also, that's kind of the tricky part, it's about the variability. So there's some within subject variability from trial to trial. Participants don't have the same reaction time every trial, obviously, right? Sometimes there's motor noise, you just sleep for 10 or 100 milliseconds. There's variability within the participants, and there's also variability between participants. Some participants have a stronger response time effect, some participants have a weaker response time effect. And these two variabilities are basically, you have to know which is which, like how large are the parts. And this is basically captured in this additional parameter Q. And I will not go into the details of this. If you want to make a statistician happen, please ask in the end how this formula works. But I will skip for now. I will just say we estimated this additional parameter, the variability, in these reaction time effects based on our own data and for other studies where we actually had the full data. So basically, we did the best that we could to estimate this parameter and then went on with this parameter to reanalyze the studies where we don't have the full data. I will not dwell too long on this because basically I can hopefully convince you based on a replication, based on studies where we have the full data, but this will also be in the background where we reanalyzed some studies. So let's actually get to the results, right? Like I hope we are all now interested in actually seeing whether the promise that Dehaene gave in 1998 holds up. And here is what you've seen before, the direct task performance, so the ability of participants to identify the prime consciously in conscious reports, here is roughly 0.2. That was what was already reported. And now our reanalysis based on the reaction time data and then using my reanalysis formula basically gets you a sensitivity that's pretty close, also 0.25 maybe. And these two are a little bit different numerically, but they are not substantially different in terms of the margin of error. So what you see here as the lines are error bars. These indicate 95% confidence intervals. This is basically if you repeat the whole study, you would expect the two error bar, the gray and the light gray bar to be within this range. And because they overlap, basically, you see that there's not much of a difference. Within the margin of errors, the two effects are roughly similar. On the right-hand side, you see their difference, and it's very plausible that there's no difference between the two conditions at all. If you're not convinced about my strange formula, my colleague Iris Sevek basically replicated the study with actual data and found almost perfectly the same result. The direct task here, the sensitivity of participants in the conscious task versus the unconscious performance is perfectly the same. Like, I think you couldn't find a better null effect. And that means that there's not really evidence for something more than what participants can consciously report in this data. But we didn't only look at one study. We looked at 15 highly cited studies. Overall, they were cited 3,000 times and more. So this is basically the backbone of the priming literature. Each of them has their own merits, and I don't want to take away from all of what they did. But I do have a problem with their interpretation that processing happened unconsciously. Why? Exactly for the reasoning. And we will have a look at some of these studies. But first, let me mention that what I told you so far, and maybe I can go one slide back, is that the sensitivity in both tasks is similar. And now you might ask, well, if you are familiar with statistical hypothesis testing, then why was the first task, the direct task, not significant, and why is the indirect task significant? Well, that is because almost everywhere in the literature, the direct task is sampled with fewer participants and fewer trials. In this particular case, we had like 10 times fewer observations trials in total overall in comparison to the indirect task. And then obviously the standard errors and the margin of error in the direct task here in the light gray bar is larger, and therefore you don't find the effect there. And that's a problem because you are basically saying we didn't look here so carefully, therefore we didn't find an effect, so participants were not conscious. And then in the other task, you look very carefully and you find the residual information that is there, and then conclude that there must have been some unconscious processing, which, as I've shown you, is a problematic reason. But now let's look at other studies. So the points that I want to make for this reanalysis was first, the trials were systematically different, but there were also other systematic biases towards the indirect task advantage, so towards showing that participants had some unconscious processing. And we left all these biases in. So when we go into the details in a second, I know you can't read it, I will zoom in in a second. I just want to warn you that the potential problems that increase the sensitivity in the indirect task, we left them in the data. We have a benefit of the doubt approach in the sense that if something may produce an ITA unfairly, we left it in. Because this ultimately makes our argument stronger because we will not see any ITAs. And then we can say, well, even if you give it the benefit of the doubt, you will not find this difference. ITA is this indirect task advantage. It's basically the idea that you have a higher sensitivity in the indirect than in the direct performance. So something beyond the unconscious, something beyond the conscious processing. Yeah. They were very different. Maybe I can zoom in into the first part. So Dehaan is the one that I already told you about. And then there's, okay, Dehaan is twice here because they actually, we took 2 studies from the same lab, but then there's Finkbeiner, also 2 labs, Kiefer, so we used a variety. It's not, we're not picking on one particular lab. I will zoom in, there's the second half on the next slide. And just so you can read this, this graph, it's basically the same graph that I showed you before where we zoomed in on Dehaan. Let me get my pointer here. So in the previous slide, we've seen the gray, the light gray bar for the direct task performance, the conscious part, so to say, and the dark gray bar here as the unconscious processing. And on the right side, we see the difference. And then I did this within the same study. There were multiple experiments or multiple kind of indirect measures. And we always here in this particular study see, well, it's more or less plus minus 0 for the difference between conscious and unconscious processing. And then you have this is more or less a null effect. So there was no evidence for an ITA, no evidence for better unconscious than conscious performance. And then we look at all the other studies, okay? And then you see some of these clear null effects. Some have a slight tendency towards this right-hand side direction. Some actually do here, if you consider the confidence interval, show actually an ITA, but these are very rare. So here's maybe one, and then here appears one more. Exactly. If you compare the sensitivity, how much was processed in the 2 tasks, it's more or less the same, except a few exceptions. You can go to another slide there. You see also here, sometimes it's even in the opposite direction, right? If you do a lot of these tests, sometimes one effect gets significant in one direction, sometimes an effect gets significant in the other direction. But more or less, you find a lot of these null results. And the point is also that these studies don't differentiate between what is null effect or what is not null effect. These studies claim for each of these comparisons, so for each of these bars that I show here, say unconscious processing based on the data. And I would say, well, for most of what you are doing, you don't even convince us that there's more processing than what participants consciously reported. So isn't that a problem? And of course, I admit there are some where there seems to be an ITA, but again, remember, I left all the kind of biasing advantages to these ITAs in the data. So for example, participants were dropped out because they had a too good direct task performance. And then, of course, you find a better performance in the indirect task than in the direct task. We can go into this detail, and you are laughing, but it's not like this is what people do. And it's, of course, problematic. And even if you leave this in, you get this pattern of results, which is not very clear evidence for what I call ITA for processing beyond what is consciously reportable. So I talked a lot. That's basically the same interpretation here. We found little to no evidence for this, what we call indirect task advantage, more information processed than they can report. And therefore, what I'm basically saying here, I'm teasing apart the argument here. I'm saying the data does not support your argument. I'm not saying that there is no unconscious processing. I'm just saying the way you try to present the way you try to make your argument is not sound. Absence of evidence is not evidence for absence. And that's all I'm trying to do. Yeah? That's all you get from this talk. You don't get any metaphysical, philosophical, theoretical perspective on consciousness. You just get psychologically psychological research tries to do it like this, and it's questionable. So what I've showed you so far is unconscious priming. But what about other studies or other fields? As I told you already, my colleague Iris Zerwek, now Schnepf, she married, found no ITAs in these behavioral replications. She then also replicated this with EEG studies. So maybe you would say, well, of course you don't find it in reaction time in responses, because response time is heavily influenced by motor noise. There's a lot of noise in when you press the button or when you not press the button. You have to look deeper, and we are able to look deeper into the brain with EEG or fMRI. If you basically take EEG data, you also find these kind of effects between congruent and incongruent trials in any ERPs or any signatures that you can find. And she analyzed this, and again, same story, found no ITAs. So even if you look at the EEG data, taking the EEG data, you can't predict what the prime was better than what participants can consciously when they try to. Casting doubt on whether there is some unconscious processing, at least casting doubt on the argument that, oh, this EEG data, this effect proves that there's unconscious processing. I would be careful about it. So we looked at EEG data, my colleague looked at EEG data, and we are also currently writing up a paper on fMRI, same story. fMRI results are also often used to provide evidence for unconscious processing, same story. Then someone who is actually not our lab, which is, we are happy about that not only we make this argument, is that Huang basically took the same argument and made the same reanalysis for go, no-go tasks. So basically these are tasks where the participant has to press a button or not, and they get briefly flashed in whether they should press the button or not. And then sometimes this flash in whether they should press the button or not is unconscious, so is subliminally presented. So it's flashed in so shortly that they have a hard time of telling you what they saw. And still their response times are then influenced by this short flash of a go or no-go stimulus. And so these reaction times could also be, in principle, or are also taken as evidence for unconscious processing, but the same story happens if participants try to identify it, they can consciously report it to the same degree of accuracy as you can when you use the reaction times to predict it. And then I brought you another one because I think this paradigm is actually quite cool, implicit learning. This one is also for you, Ellen. And we will just have a short look at the paradigm, how it looks, and then also the reanalysis of this. And this will be then the last section of the talk. So basically, this is just a repetition, repeating the same argument for a new, showing you the same type of data for a new paradigm. So the paradigm is this, and I think this is pretty cool. It's about implicit learning. So we call this now implicit instead of unconscious because there's not a brief flash of stimulus. All the stimuli are clearly visible. So it's not unconscious in the sense of you didn't see it. It's just you didn't notice some processing happening is the argument here. That's why it's called implicit. But it's kind of the same argument, and I just subsume it here as unconscious and implicit. And the idea is, this is the contextual queuing paradigm. The idea is this. You get to see these, each one at a time, these displays of else, and in each of these displays there's a T. Let's say here in the bottom one, the T here is pointing to the right. And you as a participant have to quickly look at this display and say whether the T that is somewhere hidden in the display points to the right or to the left. And you do this over hundreds of trials. Yeah? Tedious task, you just try to find the T and press the button. And now the clue is that half of the trials, half of the displays are generated randomly in you. Like where the L's are, where the T's are, it's just generated in you. Okay, so for half of these trials, you have new displays where you just shuffle and randomly generate the configuration. But then the other half of trials, it's basically a few configurations that are kept constant and always shown the same. So the exact same here, this exact same pattern is repeated. This exact, I should put it with the pointer, otherwise our Zoom members can't see it. This upper one is the same pattern as the lower one, unbeknownst to the participants. So they are not told that they are repeating patterns. And then what you see over the course of the experiment is that at the beginning, repeated and new displays have the same reaction time. Over the course of the experiment, participants get faster overall, which is expected because participants just get adapted to the task. But also, and that's the critical effect, there's a difference between the repeated and the new trials because participants somehow catch up on this regularity, on the repeated patterns, recognize them somehow, and find the T faster because, oh, I've seen this configuration before, the T is here. So they get faster in contrast to the new displays. However, so this is basically the indirect effect as before. Yeah, there's a 50 milliseconds effect here, and the interesting part also about this paradigm is that these response times are so much higher than usual. So this is 50 milliseconds is basically the lower line. You usually find 100 milliseconds. Some studies even find 200 milliseconds. Very large effect. Very, like, for reaction time researchers, this is very solid reaction times effect. And then the same story as in the priming. You now ask the participants, you show them one of these displays and say, has this been repeated? Have you seen this before? Or is this a new display? And again, your participants are very bad at this. Sensitivity 0.1 or 52%. And now the question is, again, do we have a difference? Is there more information processed in the response times on the left here than in the conscious reports on the right? And again, we need to kind of make this equation. We have to make the median split on the reaction times or use this mathematical formula and check whether there's actually more information in the response times. And that's what I did here. Another reanalysis of 20 studies. And what we see is on the right, again, the sensitivity difference, again, towards the right, it would be an indirect task advantage. So higher information processing, higher sensitivity in the indirect task and the response times than in the direct task. So the promise is that all the points are on the right, indicating more processing in the indirect task, in the search task, than in the recognition task. And again, what you see is that many, many studies show no effect. Let's skip the CM one for a second. Many of these studies show no effect. And then this one study actually has 4 data points here, 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 and here, which are clearly above. And we took a little bit of a closer look on these. And the interesting thing is, and we also asked the authors about this, and they agreed, the reaction time difference between repeated and new stimulus was already there in the very first block. This is absurd, because why would you have an advantage in recognizing stimuli that you now see for the first time? In the first block, new, and repeated displays, there's no difference between them because the repeated was not repeated before. It will be repeated throughout the experiment, but it was not repeated in the first block. And even in the first block, you see a reaction time effect. So very likely, these 4 data points, and you find this for all of these conditions, these 4 data points have some underlying confound that maybe the repeated displays were easier to solve, and therefore there was a reaction time that does not go back to implicit learning, that just was some confound. And we looked at these 4 in particular, so basically we don't believe these actually indicate implicit learning. We looked at these 4 in particular because none of the other data points show us an indirect task advantage in this data set. And that is as close to a null effect as you will ever get. Yeah. If you compare any 2 conditions, that are not like trivially the same, I don't know how you get closer to 0 effect here on the right-hand side. Okay, and that's basically the story. So we have serious doubts about results on unconscious or implicit processing because they don't provide, but the data does not provide convincing evidence for an ITA. Again, we are just saying your argument is not solid enough. That does not mean that there is no unconscious processing at all or that it cannot work. It's just be a little bit careful and look at these results with a grain of salt, especially where all this research came from. Professor Franz, my supervisor, basically started the whole research on lie detection. In lie detection, you find exactly the same thing. Maybe I spice up the discussion for just a minute longer so that you can appreciate the absurdity of what this could be in the end. I've shown you this paradigm, and in lie detection, it would basically be, you see the video of a liar, or you see the video of someone who tells the truth. You don't know. It's a suspect. And then you show kind of this trial sequence. Here you don't have the number 4, but you have the thumbnail, a picture of the person who was talking. And then as a target, you have to categorize a word into the category of honesty or not honesty. And what you find is a reaction time effect. The reaction time effect being, if you saw a video of someone who is lying, and this person's frame came up here as the prime, then you are a little bit faster in categorizing the lie word into the lie category. And the same for the truth. If someone is telling the truth, you see a picture of someone who's telling the truth, the word that is truth related is faster. It's basically an implicit association test. You find a reaction time effect, significant. Participants are very bad, 50.6% accuracy. That's what we would expect. Participants or people are in general bad at detecting liars. And then the conclusion of the study is to say, oh, you have a reaction time effect, therefore there was some recognition of the lie, but you can't do it consciously, therefore there's unconscious lie detection. Therefore, potentially, in court, you should just trust your gut. You see how dangerous this idea of, don't deliberate can be. And again, if you do this analysis, as we suggest, you find that there's actually no difference between the direct performance and the indirect performance based on the reaction time. So with the reaction times, you can't detect better who is a liar and who is not a liar than with participants' direct reports. So that was basically this part, just a bit spiced up. And just a note, again, I try to be a bit careful here. Our analysis, especially my mathematical formula, is not the best you can do. The best you can do is use the single trial data. And what we did mostly was using my formula. Ideally, the people who have the data actually would apply this median split by themselves. Then all the confidence intervals would be a bit narrower, and maybe you find some ITAs. Maybe you find some situation where maybe low-level processing of color, for example, can be better done unconsciously than consciously in some sense. So I'm saying it's possible. And it's maybe possible if you just don't use my reanalysis, but use the idea of the median split on your own data. But I'm a little bit skeptical because we left this benefit of the doubt approach in place, and I don't really think that there will be I don't think the whole field can recover from basically this reanalysis. And also mind that this was basically, it was the standard reasoning. It was basically the main way of how researchers provide evidence for unconscious processing in priming. It's the main pillar of the field, but there are other ways to do this. There are more niche ways to present data or to analyze data. And one of the noteworthy examples here is from Schimmelmitter and Forberg, who basically say, don't just show that one is better than the other, show that they can be independently manipulated. And if you can independently manipulate two things, there are at least two processes going on, and that might indicate that there's one process that is maybe unconscious. But I will not go into the details here. I'm just saying the world is big. We might find something else. With that, here are some of the reference. If you have any questions on details, please write me an email, and I will leave you with the take-home message of standard reasoning, our critique, and if you follow our critique, you basically find no difference between what participants can consciously report and their indirect task performances. Thank you.